Who was asking? Okay. Is this
Oh,
Justin? Okay, cool. Who's drawing? Who's drawing?
yep, that was me. I was gonna say, it's a many to many relationship. So we have two tables. Yeah, two users, and then a
Okay.
weak entity in between, which is basically the following entity,
Mm-hmm.
and they all have a one to many relationship to that following entity.
Okay, so let me okay. Hold on one second. So let me just draw it out what you were saying, okay?
Okay.
Hold on. Why is oh my God, this is okay. So you said that there's a okay, well, bear with me. Um, why can I delete this? Ah, gosh, hold on. All right, guys, hold on one second. Let me draw it again. Okay. And then there's another, or you want to say maybe okay, well, anyways, we can so you're thinking that there's a table in between and that relationship is, let's say, follow weak entity, right?
Yes.
Okay, and then where is the many? Where is the one?
The one goes on the user tables. Those are the
Yep.
ones with one, and then the many
Mm-hmm.
goes on the following table because that's the child in this
Yep.
case.
Okay, that's a really good. It's pretty. I will say that, this is for what we have taught so far without knowing some guidance on normalizations. This follow what I taught you. So this is a good big leap and it's close to correct. Now, how can we make this even more sufficient and even more accurate? Because first things first, there's two table that are here that are both users. So that definitely doesn't work, right? How can we change that? How can we change that? Anybody want to try it?
Is it possible to have a relationship on the table itself?
A relationship on the table itself?
Yeah, like
So
the user.
you're saying like you're saying like this, like that? I think you're getting
Yeah,
closer
yeah,
to
like
the idea. I think
yeah,
you're
like
getting
this.
closer to the idea, but it wouldn't be right, right? Because now you're
Yeah.
seeing the problem. There's many to many here.
So what if we put another weak entity in between? Like so as we go from itself to itself, we put a weak entity in the middle. I don't know if that would
So,
work. I'm just
so
like
you're
quick.
saying, okay, so you're saying this.
Yes, exactly.
Something like that, right? But
Yeah, something
now,
like
but now it would be like this. If you
yeah,
add a weak entity, right, it will be like this, right?
yeah.
Okay, you are 99% accurate. I like the way you're thinking out of the box, but you're 99% accurate. But I would just say, the way you're thinking, you're getting to the right answer. And are people following? I'm trying to understand. Does people following that? This is 99% accurate. The way that you're getting there is different than how I will approach it, right? Because how I would approach it is basically thinking about user, right? And without having another user or like doing that relationship to yourself, because you're right. Technically, you're right. You just have to simply do this because you can have user, right, has one primary keys. And you can see that in here, the follow relationship type, which is the weak entity here, is the child that has many cardinality here, right? Is there a constraint on how many foreign keys one table can have? Is there a constraint of that? Not Kaleo, you don't have to tell me. I'm asking someone. You can only have one primary keys in a table. Can you have multiple foreign keys in a table? Billy, Billy Yang, Cindy Zhang.
Yeah, you can have multiple foreign keys.
You can have multiple foreign keys, correct?
Hmm.
All we have to do here, right, in this following, now I'm making following because that's more accurate with the naming or whatever. That's a following. All I have to do is have a column call follow. Oh God. Right? All I have to do, wow, this is very difficult.
There is a text option that might be easier to use.
Yeah, thank you. All I have to do is follow E and right? Right? I can have a table that referencing the same table twice, right? As long as I differentiate that in my following table. Okay, so let me just try to make this more readable this time, okay? Oh boy. How do you remove the text then? Oh, like this. Okay. All right, let's do it again. Okay. Right? Okay. So let's say this is the user table. And let's say this is the follow relationship table, which is also a weak entity, right? And we'll have user one, hold on 1 second. We'll say Where is the underscore? You guys see the underscore? Underline. Okay. So user ID as the primary key here, right? The follow, right? I will just have first one. Followee, right? Followee is the person that you're following, right? Oh my God. Okay, so let's deal with the first one first. Okay, there's a followee here. And let's see. How do I switch back to drawing?
I think you just click on the pen. There's a pen and text, and you just click on the pen.
Where's the pen?
You don't, do you have like the sidebar with all the little icons?
Oh, there we go now. No, it was a razor before.
Oh,
Okay. All right. So we finished the first foreign keys here. Okay, we finished the first foreign keys. So we first having the follow weekend foreign referencing the user ID, which is the primary key. Right? And then what we do again here. Oh my God. Anyways, you guys get the point. It's not the previous thing, but you get my point. Right? Okay. Are you guys following? Are you guys getting the point of this exercise so far?
yes. You're
Okay.
saying that one person can have multiple followee and follower, right?
Yes, absolutely, because it's a many-to-many relationship, right?
Yeah.
So first of all, it is okay for you guys to first, while you're beginning on drawing data, and then this is a pretty advanced question. It's not the hardest question, but it's slightly more advanced because I wanted you guys to go home and think, right? So Kalelo, when you first think about the three table, it's totally legit and it totally makes a lot of sense to start thinking from there. It is totally fine because with that, you will see two user table at the very beginning and then draw like something in the middle as a weak entity. With that, it come to your conclusion. But once you practice more, then you know that the user follower and followees, they are basically the same type of class, same type of entity, right? They're just different instances, right? On top of that, you on top of that, it's just a many-to-many relationship where someone can follow multiple users and a user can be followed by multiple people, right? Different people. So it turns out to be like this. Now, to finish the understanding of this data modeling, now you also look at you'd also look at the user side. Okay, let's take a look at what I also, last week we didn't talk about, what I did here. Okay, user ID and num. Can someone guess what that means? And then tell me what underscore means. The underline, sorry, underline. Someone want to guess?
Maybe the num is the attribute or the kind of
The
form
property
user
type?
ID.
Yeah.
Yeah, type. And
It's
then the
what
underscore
type?
would I
It's a type of what? It's a type of what?
user ID?
It's a type of user ID, right? What is the user ID?
Is it the primary?
It's a
Right,
what?
primary.
It is a primary constraint. It is a primary key, but what is it? If you ignore the underline, what is it? It's a property of user table, right? It's a
Yeah.
column, or also known as the property of user table, right? A column, a variable, or property, right? Remember what we learned from the first day? Columns represent property, variables, all that, right? Details. Rows represent tuples, instances, right? So user ID is just one of the property or one of the columns, right? And having an underline here represent that this is the primary key of the user table. Okay? Which means that we can go ahead and then sort of like do a little bit more extra trivial stuff. Let's say, let's go ahead and do name, right? For example. And then we can have what? Please tell me what kind of type would I put for name?
String.
Is there string in
Oh
database?
wait, varchar, sorry.
Yeah. Varchar,
And
let's say
then
50.
the
Okay.
number. Yeah.
Yeah. Okay. Let's add one more just to finish, to make it a little more, looks a little more finished. Okay. Someone else. Let's add another one here. What can we add?
Date, maybe?
Date?
So date joined or
Date join. Yes, that's fine. That's a good one. Okay. So what would be the type? I like that we have all different types. What could be an option for date?
I was thinking number, because
No.
Excel also has this feature where you change a specific number into a date. So I think
Yeah,
that could
no.
work here too.
I'll come back to you on that. No, we won't use number here, but it's a good guess. And I see your explanation why it will make sense. Anything else that we can try? Date join.
Could it be like date, like the data type date?
Is there a date attribute or daytime?
Oh, daytime, yeah, daytime.
There is no date attribute, okay? There's daytime attribute, okay? Now, what was the last person who said number?
It was me, Arsh.
Okay, Arsh. Okay. Now, everybody listen carefully. User table right now, we'll leave it like that for now to make it look slightly more complete as a table. Now, just to finish my previous topic here, previous point, we see that you can have a table, okay? you can have a column name. Next to it, you can have a variable type. Okay? Domain, or you can call it domain or variable type. Okay, and then and then next below it is another column name and variable type, right? Date join, another type. So there's 3 columns in here, right? And then you specify the variable type. Okay, remember this carefully. This will be on your exam. You need to at least get here. Now, you can simply denote underscore here in a user ID in the case that the primary keys, as you're trying to denote here, is just a single primary keys. It sometimes work. However, sometimes it doesn't work. Sometimes it is not the case where, oh God, where the user ID by itself is the primary key. We have what combination key, right? So when it comes to combination keys, what are we going to do? If it's a combination key that compose into one primary key, right? For example, let's make an example that it is user ID and name. That doesn't necessarily make sense, but that is okay. Combination key, right? Then what you'll do is this way. Or if it was just user ID, you have the options of doing the underline. You also have another option here that is, okay. Okay. You can always put primary keys and all the other constraint in the bottom. You can always do that. Unique key constraint, foreign keys constraint, and all that. You can always do that. You can always describe it on the third box. The first very top, the header box is the name of a table. Second box of your data modeling diagram of that represent an entity. Second box in the middle, it's always the columns and variable types. And finally is where you'll put your constraints. Okay, you can always organize this way. In case of if it's combination, you must put it on the very bottom. You cannot put 2 underline within the middle part. Okay, now, similarly, there should be another box here, right? And to denote this properly, why is there, what is this? Someone drew, okay. To denote this properly, Jesus. I can do this. Right? And maybe you want to put like something like that. Something like that, right? These are optional, I think. No, I think I know it is optional. But
Wait, I have a question.
yes,
What is like the PK, FK?
PK, primary key.
Oh, okay.
FK foreign key.
Got it.
Yeah. That's where you put constraint, right? Because that's a third part of the table, right? Primary key is the constraint, foreign key is the constraint, unique key is a constraint, right?
Yeah.
That's where you will decorate those constraint in. Okay. Now, is it Ariel who are saying the date join as datetime, date join as a number, numeric? Okay. Now everybody listen carefully. I might not have mentioned this, and this is a good time to brought it up. So what you're earlier on saying that the date join here, we know this date, but you may or may not have, if you have experience in database, you may or may not have seen some datetime stored in numbers. Datetime, but stored in numbers. Can anybody guess why would database design so that there are commonly, in some case, the datetime is stored in numbers rather than using the preserved datetime variable type? Does someone know or someone want to guess?
Can I guess?
Yes, go ahead.
So my guess is maybe like it's to keep it flexible between other coding languages like Python, because Python also deals with data.
Okay,
And
so then
yeah.
let me ask you this. Why do Python... Okay, first of all, what do you mean by keep it stable? Keep it flexible.
Not like flexible depending on what the user wants to use. If they want to use number or they want to use date time.
So okay, let me then ask you this follow-up question, because you might be right, but let me this follow-up question. So everybody listen carefully, okay? This is good conversation. Let's investigate. So Rafi, tell me, if I keep it in numbers so that someone, let's say for example in Python, why would someone want to use the number to store datetime in Python? Can you answer that question?
Yeah, I'm thinking right now. I'm not too sure.
Okay. Let me first clarify. And by the way, this is not to pick on anybody, okay? We're trying to explore something, and I think this is interesting. Who mentioned the number again? What's your name? I'm so sorry that I couldn't memorize.
Arsh.
Arsh. Okay. Arsh, can you tell the rest of the class a little bit more the numbers that you see previously that you have recollections of when someone stored date join, in this example, the datetime variable, but in numbers? What does that number format look like? Is it like 0203 2025, or is this something else completely different?
No, it's actually at least in Microsoft Excel. I don't know about how SQL does it. It's
Mhm.
completely different. So if you're doing,
Okay, stop, pause. Okay, pause. Thank you, Arsh. That's good.
Mhm.
Now, just so everybody following a context here, okay? Well, Arsh earlier on mentioned that he has saw in this field datetime here, okay? We're like debating on this, but we're contemplating and debating on the variable type and options here that is called datetime of date join. Datetime is a very safe bet, very, very safe, because datetime is going to give you something that looks like let's say I just joined January 1st. No, it's going to be like something like, actually, I don't know what it's going to actually write. Like, I forgot, but it's going to be something that's very obvious. Yeah, exactly. It's going to be something that's very obvious, right? Let's say I'm going to follow what, thank you, Cindy. Let's say, okay. All right. Datetime is actually going to look like that. And it's going to, when you're opening up your tables and database, or when you are retrieving the data, it's going to show you like this, how this is how it's stored, and this is how it's going to be represented every time you open it, right? But the date join here, what Arsh is referencing, that's stored in a number in Microsoft or whatever that he had mentioned, is not something that looks like this. Just so you have it's not something that looks like, maybe some of you had thinking that what he meant by is this. Right? That is sort of just kind of like daytime, just without any symbol. No. Just to clarify, he doesn't meant that. That's not what he meant. There is a good amount of massive databases and big companies that use this database in SQL or any type of database that store datetime in a numeric format. But that numeric format, listen carefully, you don't pick numbers when you're trying to save a date time. You pick something that we call or okay? Now, listen carefully. Timestamp. Okay? Timestamp is a way of representing daytime. And most of the database will have a daytime variable available as timestamp for sure. Some database may even have equal time as a variable for you to store, but timestamp is definitely there. Equal time, maybe not, try it. Maybe not always. So I will say that Arsh, to your point, you were not wrong, but number is not what you're trying to pick from. What you need to pick is timestamp. Okay? Now, timestamp, however, okay, does look like numbers. It looks like a long ass numbers. Sorry about my friend. Sorry about language, but it looks like a long number. Something that look like that doesn't have a clue for you to match up with like 2020 or anything like that. Can someone guess what that is? Does someone know? Actually, this is not easy to get. But can someone tell me if you have an idea why and what this number represents? Okay, I'm gonna assume that maybe this is the first time you guys ever come across this. And Arsh, that's right. Okay. Okay. Now, there is a very intriguing parts where a lot of database in corporate world, in business, especially financial world, and company that has multiple presence around the world, they like to store datetime in the timestamp format. Because why? The first reason is because their time zones, right? It may get confusing for people in different time zone. If I store according to my time in USA, and when someone talks to me regarding what he's seeing while he's opening the server in London, he see 6 hours ahead, and we are talking about different things. So that is the first reason. There's a time zone difference to consider. To make something more unified, there is something called Apple time, which is 1970, January 1st, 0 hour, 0 minute, 0 second. Every single second, add 1 to it. And that we're talking about Greenwich time, which is, I believe, London time, right? So basically, there's a unified time from that on in London to add one to the number each second. So that become a unified way where every system will have a unified storage of the exact time things happen. I know we don't have to get in so detailed. It's just the time. True, I just want to explain to you in case you come across this in the future. And just because Arsh brought it up too, I described this and the reason for you. This is also why that back in, I guess like 1999, December 31st, there's a lot of people are worried about like millennial and then, like end of the world and blah, blah. That database doesn't have like a way to like store blah, blah, like daytime and things are going to go wrong. This also reject that theory for most places because a while ago people had Y2K, yeah, a lot of places has already stored daytime in a timestamp format. And people did not understand that with server and machine and database, thought that, oh, we never had thought of adding anything like 99 now it's year of 99 and now it's going to be 2000, so there's like extra like space and stuff like that is silly. I mean, some places might store it like that, but database wasn't going to be a problem because daytime representation using Apple time was used a long time ago, way before 1999. Okay, so this is just for your own reference. You could choose something that was similar to a numeric format to store the variable of date time, but it's called timestamp in the database. Don't store it using number. I mean, yes, you would use number, but the number would just every time it would not do anything. Like Apple time for you, it would translate to numbers. But if you store it in numeric, then you need to self-convert, right? So is there any question? Does that make sense, Arsh? Does that clear your...
Yes, it does. Thank you.
Does that make a lot of sense now?
Mm-hmm.
Yeah. And so for you, Rashid, is that Rashid? Is it Rashid? Early on?
Rafid.
Rafid. So for you, if you were to think about this thing, I am sure Python has it too. Python or like Java and all that stuff. And you're right. Like if in Python they were storing Apple time and all that stuff, then that's fine. But it's not the flex. If you were coming from that angle, then you're right about that. But it's not really about flexibility, like as far as like numbers and stuff like that, because Apple time, I'm sure all the different language all have that. And even if it was in daytime, right? When you're reading through Python, a database or whatnot, normally there's one thing I think you guys should have read on the driver slide when I was away. The driver do all the translations and interpretations of it. So in order to like translate or to be used by Python or another Java language or C++ or whatnot, it's not a big deal. It really isn't. But if you're saying that if you're coming through from like, using Apple time here also in Python, yes, that's correct. Okay.
Okay, I understand. Thank you.
No worries. Okay, so now we cover kind of a full-on picture here, okay, about if you guys want to take a screenshot real quick, because I'm going to erase things now. I'm going to continue using this, but I'm going to erase stuff. Okay, I'll give you 5 seconds to take a screenshot if you want to. Okay. Now, let's extend this exercise a little bit to help us, since we're already in the flow, right? Now, we use a social media example, a follower and followees. Now, I want you guys to extend this and think about it. How would I represent? Think about, this is we're still using this, that's fine. But this time around, I am going to want to represent a post. And my follower likes my post. How can I want to have something, I want to have a table, or like I want to have a database representation in data modeling to be able to indicate that, to be able to depict posts, which can be likable, or yeah, let's just leave it as likes. Okay, my follower, and let's leave it as followers. Let's forget about if someone doesn't follow me, can they like or not? Let's forget about that. Okay? So then how will we do that? How can we represent it? A post being liked. Anybody want to volunteer? Some new people?
Question: does like does it matter if the post is like liked by someone specifically? Like, do we save the
No,
data?
no, I just want to represent, I just want to represent a post being liked.
Okay, so if we have the table of the post, of the
Okay,
posts,
okay.
and it has
Hold on one second,
the
hold on one
user
second. Wait. Okay. What is this table?
it should be representing posts.
Okay. So that's okay. But can we have a little bit of filler in this, like its property and stuff?
So it should have a user ID for
A
the
user ID.
Yeah, for the user who posted.
Okay.
And if the like
So
is
user ID.
represented,
So user who posted. So everybody, please follow this really carefully, and we're going to correct if I have to Mustafa. Okay. Okay. So
okay,
user ID, that's a good one. So what would be its type?
it would be varchar because it's going to be a foreign key from the users table.
Okay. And so foreign key from user table. Okay. And user ID is the primary key. So you're correct there. It's a foreign, but it's going to
It's
be
a
a var
num.
chart.
I think it's a num.
It's a num, right?
Yeah.
It can't change when it foreign it. Okay. So it will has to
Yeah.
be following num, numeric. Okay. All right. Just to sanity, so we have a sanity here, right?
Sorry?
No, just to complete, to have a sanity in
Yeah,
this
it's
table, I'm
foreign
going
key.
to put it in a
Yeah.
foreign key here, okay?
Yeah.
Just to make it more complete so that people all get it. So, all right, so the first step, the first thing you choose is that, okay, a post will have its composer, right? Why don't we
Mhm.
name that instead? There's nothing wrong with, by the way, nothing wrong to reuse user ID, but I'm going to say composer ID. Oh God. Oh man. Why do I have to make things much more difficult? Okay. Right? You can always, in a foreign key, you can rename it. You can't change the type. You can rename it, but when you need to, either way, you need to specify the foreign key that you're foreign from using its original name. But in the table you're referencing it, in the child table, you can rename it. Okay. So that's what I'm doing right now. Okay.
Yeah.
So the composer ID, all right, what we did here is the composer ID is just the foreign key from the user ID. All right, I annotated everything here, so the variable is the same. Okay, just to make that more complete, let's make the connection here. Okay,
It's gonna be one-to-many because a user can have many posts, but the
that's
post will
good.
only have
Yes.
one.
So tell me where the one will be.
The one would be next to users table, and the
That's right.
many half circle would be next to the post.
Okay, that's good. All right, another person, help me finishing. Thank you, Mustafa. Okay, who wants to go next? Sean Jenkins. Sean,
Yeah. Repeat the question.
can you see the whiteboard?
Yeah.
Okay, what would you do next?
For connecting the user to the post, or like
It's
in terms
connected
of
already.
type,
Huh?
attribute and type. Is that what you mean?
No, so were you in class?
No, I went to the restroom real quick.
Okay, I'll pick someone else. Um, Nizar?
Yes, Professor?
Yep. What would you think we can do next? You're on mute, Nizar.
Oh, sorry.
Yeah.
I'm not 100% sure, to be honest. Can you
Okay.
a little bit guide me?
Can anybody else know what next?
Hi, it's connecting
Ethan.
the owner of the post, right?
Say that again?
The post owner.
Yeah, this is already post owner. You know, Mustafa already helped us here, right?
I
This
thought that
is
was
the
the person who
post.
liked the post.
Maybe
Who liked the post? Yeah, the person who liked the post. Okay, so what would you do with that? How would you do that? How do you represent a person liking the post?
How
Is
would
it
you
Ethan?
represent the person himself?
Sorry?
Is that what you're asking? How would you represent the person himself?
No,
Like a
how
user
would
ID
you
and a name?
represent a person liking a post? A user liking a post?
maybe drawing a relationship between
Okay, tell me
following
how to draw that. Tell me where to where?
from
From follow?
follower, like the follower who likes the post. So
It doesn't have to be follower. It
oh, it doesn't
doesn't,
have to be the so it could be any user.
yeah, any user can like your post.
So
Doesn't
from
have to
user
follow.
to post. Okay, yeah.
So from where to where?
From user to post.
Okay, from user to post. Okay. And then tell me relationship wise.
Like user likes the post, so
A user likes a post.
yeah.
So where is one, where is many?
Okay, so one user like here
Mm-hmm.
can like many posts, I would say.
Okay.
Yeah.
Okay. Is that, can a user be liked by many user? Can a poser be liked by many user?
Yes.
Yes. So
So you would create like a store, it's like to store all the users that like them.
a
Like a
store? What is a store?
Storage, like a place to store and hold all the names of the users that like
Okay.
them.
How would we do that?
That's something I have to think about.
Okay, Cindy, do you want to try?
We would just be creating more columns.
Columns?
Because here we already pointed out the relationship between who likes it. So then
Nope.
we did not.
Yeah, I mean, point it out, but is that correct? A user can like many posts. A user can like many posts. A post can be liked by only one user?
No, it can be liked by many users.
Okay, so then what's wrong here?
The one should maybe be switched. So the one should be here. Oops.
Nope.
No. Okay.
Anybody has another idea? Anybody's getting what I'm getting at? Anybody else?
Okay.
Justin? Sean, go ahead.
I was thinking maybe make like a likes table and then connect the user to the likes table and then the likes table to the post. Yeah, like that. And then user.
Oh, gave it away. Right? Okay, we're almost there. We're almost there. We have the structure. Who did this? Who did this? I have a beautiful user table. Now it looks like this. Who did that? Thank you very much. Hold on. I'm joking. Hold on. That's fine. Let me just fix it. All right. So, okay. Are we understanding why? At least let's look at the relationship here. Okay. What is the relationship for a liking situation here between user and post? Is it one to many between user and post or many to many? You have to think about it, right? Can one user like many posts? The answer is yes. Can post liked by different user? Can one post liked by different user? The answer is also yes. So their relationship is many to many, right? So understanding that it's many to many, you need to immediately have an intermediator, which is the weak entity. In here, let's just make it likes for now. to store the likes relationship between post and user. Right? Now, as far as the structure wise, that looks fine, but we are definitely missing some crucial context within the post table, first of all, and then likes table. And what is it? What are we missing in the post table?
Post ID.
Post ID? Exactly. Why do we must have post ID here? It's a tricky question.
Yeah, because we want to basically track, like for example, in this case, we want to track which post the user is trying to like.
Yes. And that's what constraint is that called?
That's a in this case it's a primary key.
It is the primary keys in here, that's right. Okay.
Yeah.
It is the primary keys in here. Okay. And then therefore we're missing something in likes. Right? What is it?
The post foreign key.
Or yeah, exactly. In the user, I think.
Does that make sense? Everybody? Is that clear now?
Yeah.
This is the I'll give this. If you get this, if the question was asked like this, and then if you get this, you absolutely get 100 point. You're basically completely there. Okay. The next thing I want to add is optional. And technically, the next thing I'm going to talk about is a bonus point here. Technically, you're supposed to do it, but I am going to let it be because I'm going to tell you in real life, no one cares anymore. The next thing I'm about to talk about. But so far, does anybody, we just spent about an hour and 15 minutes talking about data modeling diagram here and make an example and draw it from scratch with everybody participating. So far, any question before I move on to the optional knowledge? So far, any question?
I have a quick question.
Yes, please, Mustafa.
For the posts, if we have like the content, like data,
Yeah.
in general, when would we use like the blob data type?
I don't
we use it in
understand.
this case?
Can you you mean like this actually store data?
Yeah, for the posts, like when we were storing like the content, would it be stored as like a blob data or like a data type or a different data type?
So normally I'll give you a textbook answer, and I'll also give you a today's interviews answer. Okay, so what those of you who heard the word interview, it might get more interested. Okay. The post here, the textbook answer here is if it has something like in the textbook, what you will find is because the textbook is like maybe like 10, 20 years ago, it would just be somewhere in here. You would just be like saying like attachment, attachment, and then you'll get like a varchar. That will be like the textbook 50 years old textbook answer. Because you know what? Big or file, anything could be about varchar. Like, if I say 256 or something like that, right? Attachment, like it could be an image, but it could still be a file. But image, you can also put what? You can put like picture.jpg. You can give the file name in varchar, right? So if you look at the textbook, if you have read it probably just leave it there, Mustafa. Okay. But let me tell you, if you go out to interview and someone asks you to design something in the database system, and the correct answer that they are looking for, okay, will be let's say media. Let's say if it's image or whatever, right? Image, videos, or like, I don't know, file or whatever. The answer here should be, the answer that they're looking for is the location of it. Understand? You don't necessarily have to say and store that in this database, because databases are normally storing data. So it's very common for you to have a post that has like the post has a picture, or the post has a video, or the post just have a text or blob or a blog, right? But all you have to do is to have a URL that tells you where the file or the media it's being stored. And normally there will be a separate, in today's world, there should be a separate blob file storage, or like AWS S3. I don't want to get into too much because this, I'll go forever on this. Anyways, blob file storage and big, large file videos and whatever. A common solution to store them is S3 on AWS, right? Those are things that are distributed, so it can grow as the size is unlimited. It's like it just grow. It's kind of like those it's like kind of those things where like the fragment tool on your computer, it just kind of relocate for you when you're like cleaning up and stuff, so the size can like grow very flexibly. But anyways, your picture is probably going to be stored here. Let's say, okay, and let's say this server, AWS 3 server, that's storing all these blob and file, whatever. Let's say this server is like ccny cuny.edu/comsign that dot like file store, something like that. Something like that. This is a server. So all you need to do here is the media URL storing ccny.edu/school JPEG. And that is the most modern way these days for you to store the media file, the location of it in database. Does that answer your question, Mustafa?
Yep, thank you, Professor.
Yeah, this is a big key for interviews. I often do this in class. Whenever you ask the questions, what I can relate to interviews, I will tell you. And a lot of time this can demystify the interview questions. Okay, now so far, any question? This is something that are huge. Obviously the data modeling is going to be the other 1/3. I told you primary and foreign keys. And this is the second. This is the second 1/3, like 2/3. The last but not least is all the joins and stuff. right? And then basically with that, you're pretty much mastered this relational diagram database class, right? So get this data modeling and then get sort of like where you need to put your variables and columns, the type of variable, and last but not least, the constraint, which is the primary key and foreign keys. Where do they look like? And your cardinality. Get the cardinality, and then you know what? I didn't even get to any one-to-one cardinality or one-to-many. I mean, there's one-to-many, but I go from the hardest to allow you guys to think outside the box. So you have to also account for many-to-many. Sorry, one-to-many in the normal way, as well as one-to-one. Okay, those are something that you should look at, and then especially when you're doing your design of your own database for the project, that is something that you can practice on a lot. Okay, now I am going to give 10 minutes, so we'll be back at 6:50. Oh, if you need to take a screenshot, please do. Take a screenshot now, or by the time you come back, I might already have this erased.
Professor,
Yes?
sorry, I had to mute the Zoom for like the last 5 minutes. What was this thing that you added in?
Wait, you were away? Are you talking
No,
about?
I had a call, so I had to mute this Zoom.
So Mustafa has the questions on the post, because the post in social media, normally it doesn't just come with text, right? It comes with like image
Mm-hmm.
or videos.
Yeah.
So he asked, where will we store the file?
Mm-hmm.
The media file, the videos or image,
Mm-hmm.
right? So I told him there's two answers. The textbook answer is you will put attachment column here, and then you put a varchar of
Mhm.
like something like 256, right? That's a textbook answer because that will be an attachment. It will be your image or your videos and stuff like that, right? And then the varchar here can represent bits and numbers, which is the file. Or it could represent like a file name. For example, it could be like Barcelona.jpg, right?
Okay. Mhm.
Then there is the interview answer. The interview answer today is media URL. Let's say supposedly you're looking for a media that is attached to this post, like normally social media would do, right?
Yeah.
Then it's the URL. Basically, why? Because we just, for database these days, we're mostly storing data. We're mostly storing numbers, bits, and whatnot. We don't store a large file blob directly onto the database because they're files. They're not, technically, they're not really, there are data, but they're way too large for us to be able to handle that, right? To store too many. So
Yeah.
we're just really simply storing the location of it, right? Most of the time, those files are going to store on some friendly, federated, nearby storage, blob file storage, such as AWS3, right? It's the type of file storage that can save a lot of big files, like image or like a Netflix, different movies and stuff, right?
Mm-hmm.
So let's say if that server of this file storage is cdny.cuny.edu.cs.file store, which is the server of this large file storage.
Yeah.
And my Barcelona.jpg is just the file on here, right? My Barcelona.jpg, for example,
Mm-hmm.
is the image on here. Normally, answer for interview is you just need to have a variable here in the post that has the place that's to store that image location, which in this case, I name it media URL. I leave varchar like 120, like 256, but this is just so you can put czc336.edu/cs file store / Barcelona.jpg.
Okay, so it's storing the off-site like data storage location.
Yeah, you can think about that way. It's offsite, but it's this when you're designing, yes, you can think about it's outside of this database,
Yeah.
but it's inside of the entire ecosystem of whatever business database or like business system. Because this is we're I don't want to confuse you, but like obviously this is database, right?
Mm-hmm.
When you're doing system design, you also have Python server, you also have like firewall, and you have some other server, web server and stuff like that, right?
Mm-hmm.
And this is just another server that you store a large file,
Yeah.
but it's all within the friendly ecosystem. Yeah,
Got
but it's outside of this database. You're
Okay.
storing the file there, not on this database.
Okay. Makes sense. Thank you.
Okay. Mm-hmm. Okay, can you guys see my screen? Can you guys see my screen?
Yeah.
Yeah.
Okay, great. All right, any questions so far? Up to the whole data modeling? We don't worry, I always use about almost 2/3 of the class talking about the data modeling diagram and explaining about the many-to-many relationship with the sample that everybody exercise together. So it's something that I do. Let me make sure that I am recording. Okay, I'm gonna assume that I'm still recording. Yeah, it is recording. Okay, so what we saw earlier, okay, we demystify the cardinality. We start from scratch about thinking about the table that we will need, and we think about the relationship type, and we know how to handle when it comes to many-to-many relationship. And then we also dive into within the table, dive into internal to the table. What are the tables and entity, the boxes look like in the relational data modeling diagram? Okay, at the very top, okay, we have table name. Then the second parts, we have the column, also known as the property and variables, and the variable types. The last part, you keep all the constraint, including foreign keys, primary keys. Okay, and we also, just to review, we also look at where there's foreign keys, there needs to be corresponding primary keys from the parent table, right? Vice versa, right? If you have a relationship one to many, then the child table depends on how many relationships there are. And for instance, the user following example we made, there's two relationship from user to the following, right? And therefore, it's using the primary keys of user twice. So you end up having to add up. There's two foreign keys in the following, right? So you have to balance the constraints, primary key and foreign key constraints. You need to make sure that the columns are representative enough for the entity, okay? Or at least minimum what is asked for and not what it needs to do to fulfill the constraints. And you need to make sure for 2NF, many-to-many relationship is being handled by breaking a weak entity into it and breaking a weak entity into it and connect the two original table. Okay? One thing I said I was going to tell you guys that is optional, but it's totally something I am not going to be very strict about, but just in case that you see this, can I just annotate? Okay. In case you see this thing that goes like this, that's kind of like cutting the edges. That's cutting the edges. Of the table between the many-to-many, the the intermediator table between many, the transit table and stuff. This is okay. This is actually the official database way, relational database way of representing and differentiating a weak entity, a weak table, a transit table, a junction table, join table, whatever, from a normal table. Okay, when you see this, it means it's meant to be a weak table, right? I told you about what weak table means, right? It's solely foreign from the other two table, and then it was meant to just use as a transitive table and make it weak. The one way to make it unweakened, which is silly, but the technical way of making it unweakened is by adding its own primary key, which I mentioned last week, right? But just in case you see this thing that it draws four angles, like cutting the edges in the table, it just means it's a weak entity, right? I don't care if you guys draw that or not. Like, it's not something that once you're in real life, people like care about. Well, I guess I shouldn't do it. I shouldn't say that, but I guess, like, you know, for academical, for theoretical purposes, you should do it. You should draw that if it's a weak entity. And if you want to make sure people know that it's weak entity, you should draw it. Otherwise, once you go out there in real life, without it, people still get what you mean. Okay? Anyway, all right, so let's move on. Let's just take a look at something that you should already know by now. Okay, how do I have this table from here? An item and transaction. No, this is not. Yeah, it's a assignment. It's a assignment table, many-to-many relationship table. Okay, I guess this is the kind of reverse engineering. Okay, take a look at this. So this is an exercise between students and assignments. Okay, so students can have multiple assignments, multiple different assignments, assignment A, assignment B, assignment C, D, E, F, right? And one assignment can be done by Shang, can be done by Jackie, can be done by John, can be done by Mustafa. So they are, in this context, they are many-to-many relationship, right? So let's look at, and I'm sure you guys all have seen create table before in my previous lecture recording, but let's review it. Let's look at student. Now, student table has a SID, that's stands for student table, but SID is totally clean and fine, and it's in integer, right? And we early on put numeric, that's fine in Microsoft and Access and stuff, but most of the database, MySQL, it will take integer, okay? Integer, that's fine. Not null, whatever, that's cool. Well, you don't really have to put not null. Can someone tell me why? This not null here is kind of redundant. Can someone tell me why? Putting a not null here, given that there's something else that is in this create table, given that not null here is really redundant. It will be not null anyways. Can someone guess why that not null is not really necessary? Additional default not null value is not necessary. Why?
It's a primary key, and
It
primary
is a
key is
primary key. Can primary key be null?
no.
It cannot. So this primary key constraint here is going to ensure this SID is not null anyways. Okay, so it's not wrong, but it's not needed. It's duplicate to do the same thing. Okay, now last name not null here, that's fine. Because then this is the constraint that you want to specify, telling that I don't want last name to ever be empty, or I will throw an error. Okay, last name, first name of the student, that's fine. And then at the end, we say primary keys. And then we said SID is what we will dedicate into the primary constraint. So it's primary key. Similarly to assignment, you know, AID stand for assignment ID, and then it's a primary key. So not null here again is redundant. Due date is the date time. Okay, that's pretty easy. Now look at how the syntax here: student followed by parentheses, right? And then close at the end of a create statement. There's a semicolon to close it, right? In between every line here of variables, declarations, you have a variable name, property name. I don't have to go through all this again, but I'm just doing that just for the sake of reviewing. But property name, domain type, variable type, comma. Then you say the second variable name, variable type, comma, right? And then the constraint also is another line. If you're putting not in line, in this case, it's not in line, and you put it under everything during declaration of variable and they put it on the bottom, that's fine. But you have to be after a comma. Okay, just make sure this is the syntax. Okay, on the test, what we're doing this semester, your syntax is going to be very important. This parenthesis, how it's written, the close semicolon, the comma, all these are going to be very important. Primary key declarations and stuff like that. Okay, just make sure you practice it. I'm sure you're practicing it one way or another in HackerRank right now that I assigned you to do. And there's 2 homework previously that has create table that you should have practiced it, but there's a lot of exercise out there online or whatever, and you should do a little bit self practice on these compiler to make sure your syntax, you got it down, at least for this semester. And now look at how many-to-many relationship table we create a weak entity table, referencing table, also known as the child table in this case, right? It's called assignment submission, right? A lot of time that weak entity table is in an awkward moment where like you don't know how to name it because it could be the verb, that's fine. But sometimes the verb has been used somewhere else. So you just end up using the name of student and assignment. That will be okay too. You just use the both parent name. That will be okay too. And in this case, we thought about something assignment, submission, blah, blah. That's fine. That's the actions between it. So we have obviously declarations of a variable again, SID in, AID int. You need to declare it even though it's foreign key that you end up going to add it into. The constraint that you're adding into is a foreign key, right? In here, right? Referencing the student ID, SID table, whatever, right? It's a foreign keys. You still need to declare it, right? Because you still need that column, SID column, to exist in the assignment submission table, right? In order for you to store each of the primary key from each of the, the parenting table. So you need to do this job in order for you to make that constraint, right? So don't forget that. Okay, and then let's say the assignment, each of assignment of a student of each different assignment, there's a score to it. That makes sense. The time that you're turning that in, that also makes sense. Okay. Now look at this. This is, a typical transit table. Once we added assignment ID int and make a primary key out of it, it now become non-weak, non-associative, whatever you call it. It's just a normal table. Although the job here primarily is still doing the same thing, which is connecting the students and assignment and then present it as an assignment submission action. But now it has a primary key. So we no longer call it. It cannot be called weak entity anymore because it has its own DNA, I guess. Okay, any question? Now, have you guys used this tool already, some of you, in homework 2? Called Draw SQL? Draw SQL?
No, I use a tool for on Confluence.
Confluence is fine.
Yeah.
Confluence has, what does it use?
Um,
Well, Draw SQL, you can also import that into Confluent maybe. Anyways, it doesn't matter. It's if you guys have been drawing on some of your preference tool, that's fine. There's I forgot, there's a couple of different ones to draw SQL. I personally like the Draw SQL here. It's not really conventional, as you can see that it has the first and second box here, and then the primary keys is kind of like this, annotated like a key next to the name of the variable. And also it doesn't have the one for one to many. So that's the only two things that is kind of not unconventional, but it's very easy to use and it's free and it's browser based, called Draw SQL. Draw SQL, if you guys are interested. Okay. So this kind of just represent the previous table over here of the create table and these two. I need you guys to really come back and look at this and then be prepared to do very similar to this on your exam. Okay? Now, we're finally taking a leap back and we can talk about something that I mentioned so many times before. And finally, we can introduce you to normalization. Okay, so if a table has data redundancy and is not properly compartmented, then it will be difficult to handle and to update. Basically, it will be difficult to store because it has redundancy, so it may grow exponentially. I'm talking about the redundancy may grow exponentially, right? And because of that, it slowed down the writing even. Not even just a storing of taking up space, but the fact that it takes up space and memory, it would impact writing into the database as well, right? And it would also eat up extra memory space and doing insertion, updates, and deletion, right? And also, it become hard to read, as I mentioned before to you. Like, if there is no guidance, you're not following any type of policy, it's just a brain dump version of data modeling design and have no consideration of good practice. We call it denormalized, right? But normalization has multiple degrees, okay? As you can see in the picture below. 1 NF, 2 NF, 3 NF, B, C, and F. Okay, so 1 stands for first normalized form. 2 stands for second normalized form. 3 stands for third normalized form. B, C, and F, later on we'll talk about that. It's known as 3.5 normalized form. And then there's 4th and 5th and 6th and 7th. But really, we stop around 3 and F. Like, we don't really dive that much further after 3. But for all the purpose of this database course, you got to do everything at least 2 and F, period. You have to do everything at least 2 and F. Okay? Now, when you see this graph here, that kind of look like this, like circulate 1 and F on the very top and 2 and F and 3 and F, how do you interpret what this circulation means? And what are the relationship between 1 and F and 2 and F and 3 and F? How do you interpret this picture?
I was thinking more in terms of size and distillation. So 1NF will be the biggest, I guess, normalization function, and then you can do another normalization function to get to 2NF, which will be a smaller thing.
Maybe we're thinking about the same thing, but maybe we expressed it a little different. When I reveal the answer, maybe you tell me if it's the same. Anybody else want to try when they see this symbol? What is that symbolic of? What do you think of out of 1NF to 3NF relationship based on this picture?
The different variations of like how many degrees of data is like planed
So
in.
then, yeah, but even that, so what does that tell you about the relationship between 1NF and 2NF? So the answer I'm going to reveal, we don't have that much time. 1NF is a superset, right? Meaning 2NF is a subset of 1NF, meaning like if you need to be 2NF, you need to be at least already at 1NF. Okay? 2NF is a subset of 1NF, meaning like if I call a design, database design 2NF, I already know that this database must already have been a 1NF. Okay? If I call a database design in its third degree form, third normalized form, then by default, it automatically was already a first normalized form and second normalized form database design. It's just getting more and more compliant in the higher the number, the more strict rule, but all the rules are piling up and added on. Okay? And you look at this graph, it also, in another word, it's also saying that out of the entire database world, design work, and out of the entire database design, okay, let me see. Out of the entire database design, all right, where is the damn pencil? Okay. Okay. You got all these that are not. These are all, let's say this rectangle represent all the database design, all the databases, right? You got all these outside of 1NF, 2NF as not normalized. All these white place, right? And you got only the normalized in the circle, right? So there's more of those database that are in first normalized forms, obviously, than the second normalized form, right? Because people could probably start cleaning and then start standardize everything, start complying with normalized form up to the first normal form, and they stopped. Or maybe people will start doing 2 and blah, blah, and after they're finished 2, they stop. They don't do third. So there's always the size-wise of population of database. There are more in one normalized form than in second normalized form, and it gets smaller and smaller. Okay? But by default, just understand not by default, the rule here is in order to be second normalized form, your database must already have been first normalized form. Okay? In order to be a third normalized form database, your database has to already been second normalized form. It has all its features of second normalized form, which means it would have already been a first normalized form. Okay? All right. So let's look at the rules of each normalization. Oh, I knew this. Okay, let's look at the first normalized form. No mixed domains. No duplicate columns. No multiple value in one column. Okay. Now, first of all, let me just tell you, instead of having you ask you this question. Let's look at the restriction here of first normalized form, and all the other ones later on, that's fine. But let's just look at the first, all these rules here, and then there's three here in the first normal form. Okay. No mixed domains, no duplicate columns, no multiple values in one column. Okay. None of these, and then by no duplicate column, it means that you can have a column that is like, like for example, early on the user table, right? You cannot have a user table and then you will have like followees column, followee one column, followee two column, followee three column, and so on and so forth. That with a uncertainty of how many followee you have. And then you just have 1, 2, 3, 4, 5 that are like generic, but you're adding 1, 2, 3, 4, 5, 6, 7, 8 in order to store like numbers to it. That store different followees, right? It's not saying something like followee and followee in like the table, because if you have a followee column twice in one table, there will be a runtime error. You will not be able to even create that table. If you're trying to update the table so that it has two columns called followee, the table, the database will not execute it, right? But in this case, what it's saying here is you're having a column 1, 2, 3, 4, 5 of followees in order to store almost like a data structure of it. That's not allowed here. Basically, what I'm trying to get at here is that if you look at all these three rules, no mixed domains, no duplicate columns, no multiple values in one column, none of these are runtime error. None of them is compiling error for database. Normalization, the point of normalizations is not to get error checking. It's not doing error checking here. You're gonna leave this college one day you graduate. Don't come back one day and don't think back one day and say, Professor Sheng, say and argue with your colleagues and tell them saying that, oh, this is not first normalized form, this is not second normalized form, so that it will fail when you're trying to create the tables in database. No, don't ever put my name in there, because it's not, normalization is not meant to check errors. It's not meant to make your database error-free so that it can run in database. It's meant to make your database design more productive, more efficient, and it's to make sure your database are going to have its own longevities, and it's going to be able to be more flexible, no redundancy, more readable, and also, last but not least, it might be hard to learn now because we haven't got to the abnormally topic yet, but the primary keys and foreign keys, not only do they have constraint when you are creating them in a table at the creation parts, but during the deletion, there are certain rules we're going to talk about later on. If your database is now normalized, those rules of the foreign keys and primary keys constraint could be easily accidentally violated. Okay, those rules could be accidentally violated, and we'll talk about that part of unnormalized database later. But my point here is, look at all these rules here we're seeing. None of these rules are really preventing you from running the SQL when you're trying to stay creative or whatnot. It's meant to make it more efficient, and it's meant to make your design better. So that's number one. Now, let's dive in the last 10 minutes just to the first normalized form and what these three things mean. Okay, so the first normalized form, okay, the first rule is there are only single value attributes. So look at this. Look at student phone number here. There's two number here. 971 blah blah and comma 997. Well, you're thinking this is someone who using a cell of database, a block of a database to store a data structure, an array. This is definitely a programmer or some sort. This is a violation of first normalized form rule. Why? Because you should only store single value. Again, no multiple value in one column, right? This column and all the column, in order to, look, this table could be there in the database somewhere in the universe. But this is not following the first normalized form. The first thing I can recognize is that there is a data structure here that represents like some array, and then it has multiple value. That is a violation of first normalized form. Okay, that's one violation. Attribute domain does not change. What is domain? Remember when we first talk about introductions of what columns and row means, and columns the property, and then property has a type, right? Remember I mentioned that there's a type and there's a domain. Okay, the type is the strict database reserved syntax, like, type meaning like it's a varchar or if it's a number and blah, blah, that's type. What domain means is that you're storing phone number, which is in the number type, numeric type, but then you're storing salary, which then is also number type in the same column that's called salary. All of a sudden, different row you're storing for different purposes. That's a violation of first normalized form. Because why? Because you're changing the attribute domain. The type is the same, right? But you're altering what you're actually storing in the column. Just because they're same type, variable type, which is numeric, you're storing one that is your salary, which represent dollar or whatever salary. Then your another column, you use it as storing a phone number, also in numeric. That's another violation. Okay, so we went through two violations here. Okay. The third violation, as I mentioned before, if you have a table that exists student number twice, it's a violation of the database. It's going to be an error, right? But what we are saying here in the normalized form is you need to have a unique name, meaning like you shouldn't be storing a unlimited or never-ending simultaneous domain in one table by separating or adding 1, 2, 3, 4, 5, like, you know, student 1, student 2, student 3, student 4 kind of thing. Right? You're not supposed to do that for first normalized form. Right? That is what it means here. There's a unique for every attribute. And you might ask me this question. What if I'm storing my father and mother name? And then so I put parent 1 and parent 2. Now, that's slightly different. And there are some exceptions that you can make. And if you know that, okay, the parents is up to 2 numbers, and you could do that, sure. That is the small little exceptions that, you know, that's fine. If you have a finite number of that, like if instead of storing father and mother, you want to store parent 1, parent 2, who knows, because you could have 2 moms and or something like that, right? But you could still also, either way, that's an edge case, right? Like, you know, parents, you know, is 2, for example. But this specific restriction here that meant for you to not store any duplicate names by adding 1, 2, 3, 4, 5, as well as there's only one single value. These two restrictions and rule of first normalized form has basically, if your ringing a bell, has basically already resulted in something that we just learned, that we just spent a lot of time discussing today. If you can connect the dots. And I'm going to leave you guys to think about what I'm saying as the next week I'm going to ask. Let me repeat that again. The first part of today's class, we're doing a lot of data modeling exercise and stuff. And also at the very end of last class, I kept on mentioning that we are drawing the data modeling, we are coming up with data modeling and the design following second normal form. And look at this. There are only single value attributes, meaning you cannot store arrays and blah, blah. So you cannot do multiple value in one column already. And you cannot also have follow E1, follow E2, follow E3, follow E4. Does that now kind of come in full circle of what you're realizing? Why there's certain rules for us about what we did this early on today's class? Okay, I'm gonna leave you out there. That is what I'm hinting. Next week, the first part of the class at the very beginning, I'm gonna ask people to tell me what am I saying and what you guys are getting at after learning first normalized form. What does this has to do with what we so far has been following the rules that I've been teaching about the data modeling diagram? how do you piece these two together? That will be something for you guys to think about. In addition, there will be homework publishing today. I will, as soon as I did that, I will let you guys know on Slack.